So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then the return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done or else you can read the code. So let us see from the procedure. What we are doing for searching: key element, checking, next check, next. So we are comparing the elements. How many elements we are comparing? At most how many? See, if I am searching for 2, then I may be performing all n comparisons, means depending on the number of elements. Or if I am searching for 8, then I may be getting an element in just one comparison. So if you look at the code now, this loop may repeat up to the end of a list, or if at all the condition is satisfied in the beginning itself, it may terminate. So this loop may repeat minimum for 1 time and maximum for n time. So the best case is that if the element that we are searching is found at first place and the time is order of 1, best case time is 1. And the worst case is if you are searching for an element which is present at the last index and the time is order of n. So worst case is searching for last element, or the time taken for worst case is order of n. This is case of successful search. What about unsuccessful search? If the key element is not found, then always it will check all the elements, then only it can inform you the element is not there. So for unsuccessful search, time is always order of n. It's maximum time, always maximum time. So unless you have reached the end of the list, you cannot say that the element is not present in the list. So the time taken is order of n. So this was the best case and worst case I have shown you. Now one more thing. Let us look at average case time also. Average case time may not be easy always, so we may not be performing it always because it needs a lot of efforts for doing analysis. So mostly we are dependent on worst case or also best case. Now let us see average case. Let us check. So best case is searching for an element present at 1. Worst case is searching an element present at last. Then these are 2 cases. What are the other cases? Searching for an element present at index 1, that is second element, or the third element, or the fourth element, or the fifth element. So these are all possible cases. Then what is the number of comparisons done for checking if the element is present? Then what is the number of comparisons required if you are searching for first element? Just 1 comparison required. Then what about the element at second location, that is index 1? 2 comparisons required. So the case, if you